So hello all, let's continue on this Telangana mechanical paper from 2024. So we are covered till question number 117 in the previous video. If you guys haven't covered them, question number 1 to 117, question number 101 to 117, please go through the video number 1 and video number 2. Then you can jump on to this current video where we are going to discuss regarding regarding the remaining questions. Clear? So if you take this next question, question number 118. 118 is given like this. The question number 118 is given as the commonly used material for making jigshin fixtures is. So basically jigshin fixtures are to hold the workpiece, hold the tool or grab something. So basically they are used to hold something. They should be made up of a material which is very strong, sometimes heavy, very hard and so on like that. So this should be very strong. If you are using copper, if you are using wrought iron, zinc, these are all basically very softer materials. You guys know non-ferrous metals are of lesser strength, lesser melting point, etc. and so on. So we cannot use copper, we cannot use zinc, etc. Wrought iron is very basic iron, so it contains very less amount of carbon. It's a very low, it has a very low carbon steel, or it's having very less amount of carbon. So as less amount of carbon is there, it is not strong enough. So we cannot use it basically to hold the workpieces or anything. So we cannot use them for making jigshin fixtures. So the next or the better one which is there in out of all the options is option number C, which is mild steel. Clear all? So we need to go ahead with mild steel, which is the stronger one as compared to the other three elements here. Clear? I hope it is completely clear to you all. So jigshin fixtures, we just in the previous question understood about a jig. So jig is used to hold the tool or a workpiece so that the tool is pointing at the exact point on the workpiece. You need to understand that one. Clear? So it should not create a hole or anything in some other place. So we need to hold a tool or a workpiece, it should be very strong enough. Same thing goes for fixture as well. So it should be holding the workpiece or a fixture should be holding a workpiece or a tool very strongly. For example, you want to do carpentry operation or you want to do shaping operation. The workpiece need to be grabbed very strongly. Let me show you with a picture. Question number 118. So for example, you want to do shaping on a workpiece like this. You want to do shaping on a workpiece. So you have the fixture. So you will be holding somewhat like this using something, and here also something will be there which will be holding it very firmly. Okay na? Clear? So this is a fixture. It should be made up of a very strong material. In fact, if you do or observe in a workshop or a carpenter shop, you would observe that these are very strong material. So you need to use a very strong material to create a fixture or a jig. So the best material which is there within these options is nothing but mild steel. Clear? That's how the answer for this question is option number C, which is mild steel. Let's proceed with the next question. In the next question, it is given that the following electrolyte is used in electrochemical machining process. So we guys know electrochemical machining process is a non-traditional process where the chemical reaction would be causing the erosion of the metal. So from the surface of the metal, you will be removing the metal by chemical reaction that will be occurring there basically. So in that you need to use the electrolyte or basically the solution as actually brine solution. Brine solution means what? Salt solution, NaCl, brine solution. If you take some water and you put salt in it, it's actually nothing but a brine solution. Clear? So depending upon the amount of concentration of salt which is there in that, you would be calling it as highly concentrated or less concentrated or average concentrated or medium concentrated. So we need to use a brine solution because we need Na plus Cl, Na2 plus, Cl2 minus, all those ions which will be coming up as soon as they lose the electrons or gain the electrons. we will not be using water, we will not be using kerosene, we will not be using linseed oils. So you guys know these kerosenes, linseed oils are not good electrolytes. We cannot break their bonds. Generally they are actually hydrocarbons. Clear? So it's difficult to break their bonds, or basically will be causing them to burn. If you want to burn it, for example, you take methane or anything, so CH4 or something will be there. So if you burn it, you will be giving rise to carbon dioxide. Understood? So you are giving rise to heat only, or basically you are getting heat itself. We don't want that. So we need to use brine solution. So you can see that the chemical reactions which occur in this electrochemical or in this process, which is given full name as electrochemical machining process, not electrochemical machining process. You can see you need to have this iron rod is there, it is losing electrons, it is becoming Fe2 plus and losing electrons here, and hydrogen at the anode or whatever the cathode tool is there, we have 2H plus, it is gaining electrons and you will be getting hydrogen gas. And see here, we need Na plus, what OH minus is coming from water and it is actually making NaOH, and Fe2H is bonding with 2OH minus and it is giving rise to FeOH twice. So most importantly, we need this Na plus, we need this Cl minus as well. So which will come only when you are adding salt into or NaCl into water, which is nothing but when you add salt into water, it is called as salt solution or brine solution. Technically speaking, it is called as a brine solution. So we need electrolyte to be brine solution or water added with NaCl, hence the answer for this question number 119 is nothing but option number D. So we are done with 119 question. Let us proceed with question number 120. So look here, in this 120th question, they are asking that in a linear arc welding process, that means we are using arc welding. So electric arc is giving rise to heat, electric arc is touching the metal and it is giving rise to heat, hence the metal is experiencing fusion or it is experiencing liquidity and all. So we are using an arc welding and it's a linear welding, that means we are going on doing the welding operation on a straight line. On a straight line we are doing the welding operation. The heat input per unit length, so per unit length how much of heat is generated, and that heat will be causing the metal to fuse, right? So how much heat is generated is inversely proportional to, they are asking which one will be causing the less heat to go on to the workpiece anamata. So let us go one by one. Question number 120. So question number 120 basically, question number 120 basically, okay. So in this question number 120 we have this, so first one is, first element in this one is nothing but welding current. So welding current is there, welding current. So if you have a workpiece like this, okay, and you want to do welding operation, so welding current, more is the current, more will be the heat generated, because as current is going and touching the metal, metal will be experiencing or metal will be having resistance. So the heat, if you have studied electricity magnetism chapter of physics, you would be understanding that heat generated will be proportional to the value of current, or more is the value of current, more is the heat generated. So more is the current, more is the heat generated, more is the value of the current, more is the heat generated. So it is not inversely proportional to the welding current, heat generated is not inversely proportional to welding current. So first option is absolutely wrong, okay. If you see the second option, they are talking about welding speed, which is the correct answer. Let me show you how. So in welding speed, so when you are doing welding operation along this line, you need to move our welding gun, whatever the electrode is there, that should go at an optimum speed. It should not be going very fast, it should be going with an optimum speed. When it is going with an optimum speed, what happens is, when it is going with an optimum speed, you will get sufficient amount of time for the current to go into or penetrate into the workpiece. Understand? So you will have good amount of heat going there. So lower is the speed, higher is the heat generated. lower is the speed, higher is the heat generated. So speed is inversely proportional to heat generated. So our answer is correct. Our answer is correct. Okay. So speed is inversely proportional to heat generated there. So that's how we can say the answer is option number 2. We can check the other two as well. Just like welding current, welding voltage as well. So more is the voltage, you will be able to create more value of heat generated. Understand? So power is equal to I square R. I is current, R, or you can write down as power is equal to VI as well, voltage into current. So power is equal to voltage into current. More is the value of power that is produced by more value of voltage and more value of current. Let me write down that as well. Question number 120 only. Next slide. Okay. So power is equal to voltage into current basically. Understand? Okay. So power means basically this will be proportional to heat generated, right? So more is the voltage, more is the heat generated, more is the value of current, more is the value of heat generated. So this option number C, voltage, is absolutely wrong. Just like current, so more current is there means more heat is generated, more voltage is there means more heat is generated. So it is not inversely related. So third option is wrong. Next is duty cycle of power source. This also. Okay. So you can understand that one. So more is the duty cycle, you will be having more value of power. Clear all? So that is the thing. Our correct answer for this question 120 is nothing but option number B. Let's proceed with the next question. Question number 121. It's a very theoretical question. They're asking that Babbitt metal is an alloy of. So Babbitt metal is basically used. Babbitt metal is basically an alloy and it is used in making ball bearings, etc. So that it is not experiencing corrosion and all and so on like that. So it is made up of copper, tin, antimony. So these are the elements there. You need to keep that thing in mind here. Understood? So it is made up of these materials so that it has the properties of good surface finish. It can do pure rolling motion because every ball bearings ball should do a pure rolling motion on the surface and so on like that. So we need to use this particular Babbitt material which is made up of Babbitt metal which is made up of copper, tin and antimony. So question number 121 is done. Let's proceed with question number 122. So 122 is also again theoretical question from material science. It is given that white cast iron contains carbon in the form of. So we guys know cast iron. So cast iron is the type of iron because you are getting different types of iron or basically nothing but steels by adding different amounts of carbons. Okay. So based upon the amount of carbon present in it, we are actually getting the value of that respective steel. Okay. And cast iron is a high carbon steel and it has least amount of melting point there, and in this one they are telling the white cast iron has the type of carbon as which is nothing but cementite. Clear? These are not flakes, spheroids of steel, basically it is specifically called as cementite. Understood? Clear all? I hope it is completely clear to you. Let me show you the value of the carbons as well for low carbon steel, high carbon steel and all. So I am taking the theoretical notes here. I am taking the theoretical data. So low carbon steel generally has less than 0.3% carbon. Medium carbon steel has 0.3 to 0.6%, and for high carbon it is more than 0.6%. Our cast iron will be having 4% carbon, which is very high. So it's a high carbon steel only. And the type of steel which is there in white cast iron is nothing but cementite. Clear? Okay. So Fe3C is the cementite here. Done. And next question, the process of reducing iron ore to pig iron is called as. So basically whenever you want to produce iron, clear, so it is available in the mines as iron oxide, which you call it as bauxite. Let me write down those, otherwise you will not be able to understand that. Question number 123. Iron ore, which is nothing but Fe2O3, Fe3O4 and so on like that, which we call it as bauxite. So in blast furnace, what we'll do is basically we use the process called as smelting. Clear? And we will be producing iron. Okay, na? We'll be producing iron, but this will be having, it will have good amount of carbon, almost like 3.5% to 4.5% carbon. Understood? So this process is called as smelting. Clear all? This process is called as smelting. Understood? Clear? Let me write down, let me show the screen here. So if you observe this process of reduction of iron ore to pig iron, okay, we are producing first type of iron which has good amount of carbon. We call it as pig iron. Understood? Clear? I believe it is completely clear to you all. And if you see the other processes, first one is annealing. Annealing means it is basically heat treatment process. That means after producing the machine element, after doing the machining process, after everything, the last step is that one. After producing the whole element, the last step is heat treatment process. You will take it, and if you want to have that metal or material to be having good ductility and all, then what we will do is you will heat it to a temperature and then slowly cool it. We call it as annealing. If you suddenly cool it by dropping off in some water, dropping off in some oil or anything, it is called as quenching. Those are all heat treatment processes. Okay, na? So smelting is the actual process where the iron ore which is having oxide is reduced to pig iron. Okay, na? So oxygen is gone. You are left over with only carbon, because in smelting process you will be adding carbon. Carbon will be reacting with oxygen and some carbon dioxide is gone, but some carbon will be somewhat entrapped inside it, so you will be having good amount of carbon. It's called as pig iron. Carburizing is nothing. Okay, so what you do is basically, carburizing is basically you would be depositing carbon on the surface. Carburizing is where you are depositing carbon on the surface, because more is the carbon, more is the strength of the iron, more is the carbon on the surface, more is the hardness also. So if you want to get hardness on the surface, for example, if you take brick, itika iskondi, itika is very strong. If you drop brick on your leg might break, but it is not strong on the surface. You can simply use your nails to rub on the surface. So if you want to get strength on the surface as well, or hardness, basically strength on surface is called as hardness, then you would be doing this carburizing process where you would be depositing carbon on the surface. And the next one is normalizing, basically. Okay, and what we do in this one is, it's also heat treatment process where you would hold it at the temperature for some time. Annealing is from that high temperature you will slowly cool it. Normalizing is you will hold it at that particular temperature for some time. Quenching is you simply drop it from the temperature. Smelting is anyways the process, and carburizing is depositing carbon on the surface. Clear? So this is very clear, and we have the answer for this question number 123 as simply option number smelting, which is option number B. Let's proceed with question number 124. It is given that the slow and progressive deformation of a material, with time at constant stress is. The slow and progressive deformation of a material with constant stress is. So if you guys know, if there is constant load, correspondingly constant stress, if the strain is going on occurring, we call it as simply creep. Fracture is basically where simply breaking will happen. So breaking is called as fracturing. There is no doubt in that. Fatigue means basically you have an element, like for example you have bridge, you have something like a bench or something, okay, or you have something like a mixer or anything. So basically on the first day of using it, it is not breaking or collapsing, but you are using it for many years. A bridge is there, every day traffic is going, traffic is disappearing, so dynamic loading is there. So what actually happens? Fatigue. For example, you are preparing for ESET from the morning, you are continuously preparing for 10 hours, 12 hours like that. What happens? As you stretch beyond 10 hours like that, or stretch beyond 5 hours like that, you will experience fatigue. Ante simple calculation kuda mistake chesta untaru. So fatigue means basically losing of capacity over time. due to dynamic loading. So you will study in a more detailed way, or you might have studied in a more detailed way in design of machine elements. So fatigue comes there. It is not basically according to the statement. Constant stress thing is not there. In fatigue, stress will be going on changing. Non-zero, zero, non-zero, zero, then only fatigue will be coming into existence. And in fatigue also, in fracture, it is about breaking into two pieces. It's not about constant value of stress or constant value of strain. Next one is grain growth. No, grain growth or everything is internal. It is not at all related to this constant stresses thing. The only answer left is creep, and creep definition is basically at a constant stress, strain will be going on produced. So we are done with question number 124. Let's proceed with question number 125, 127, 126, 125. So the question number is not there, but remember it is question number 125. So in this question number 125, it is given that puddling is the process of producing. Puddling is the process of producing wrought iron. Man indakala chusam kada, smelting is the first process. We use a blast furnace, and what we do, we will convert the, let me show the diagram. We'll use this blast furnace and we will convert. We'll use this blast furnace and we will convert this iron ore to pig iron. And from here, pig iron, which has this carbon 3.5% to 4.5% carbon, which is very high. If you have this much amount of carbon, it will be very, very brittle. Example, for example, 4% carbon will be there in cast iron. Cast iron is very, very brittle. It cannot be ductile at all. So we don't want that much carbon to be there. So we will use this process, puddling, to reduce the carbon. To reduce the carbon. To reduce the carbon, and we will have wrought iron. Wrought iron means it is a type of pure iron. It has very, very negligible amount of impurities. It has very, very negligible amount of carbon inside it. So wrought iron is used to even building ships when steel was not developed at all. Steel was not actually done. Ante ee material science iron carbon diagram idanta jaragaka mundu wrought iron baga use chesta undevallu. But later they have observed that adding some carbon, ante ippudu up to 0.8% చూసాం కదా. What is the value for high carbon steel? 0.6%, more than 0.6% carbon. So more is the carbon, higher is the strength there, but you are compromising on ductility as well. So based upon the properties you want, if you want to get high ductility, you want to have higher brittleness, or if you want to have higher hardness, etc. and so on, there are other things like knot sensitivity, etc. You will be putting that value of carbon. For example, sometimes you want to have no rusting at all. So we want to have stainless steel. So steel, that is iron added with carbon, is added with something like maybe like chromium, vanadium, etc., which will avoid it from experiencing rusting anamata. Clear? So puddling is the process where we will convert it into wrought iron. So you can see the options here. So this is the answer. Option number C is the right answer for this. So option number 1, cast iron, no. The pig iron itself is an example of a cast iron. Clear? Stainless steel, I told you already, we will be adding carbon later, and also we will be adding other elements also like vanadium, chromium, etc., so that rusting is avoided. Pig iron is anyways already there, which is produced from smelting process. So our answer is option number C itself for this one. Question number 126, right? It's given that mild steel belongs to which category of the steels? Low carbon steel. Mild steel has lesser carbon basically. Okay, it is not having carbon more than 0.6%. It's having generally around 0.3 like that. Okay, na? 0.3. So where it is the boundary for low carbon steel. So the answer is it's a low carbon steel. It is not high carbon steel or no carbon steel. For example, if they are given wrought iron, you might use no carbon steel or negligible amount of carbon steel. Or if it is there is no carbon at all, it's actually not called as steel at all. It's actually called as iron. So for question number 126, the answer is option number A, low carbon steel. Let's proceed with question number 127. This is a question from, again, properties of the materials only. It is given that the ability of a material to be flattened into sheets is very good. First of all, if you want to deform its shape into some other thing, definitely it should be a ductile material first of all. So when it is a ductile, it can be drawn into a wire, it can be drawn into a sheet or anything. Basically it can undergo some plastic deformation. If it is brittle, it cannot undergo any plastic deformation. Clear all? So if it is non-brittle, then only it will experiencing, no, it is non-brittle, then only it is, when it is ductile, then only it will undergo some plastic deformation. Clear? So ductility is a general term and it is used to for referring to making into wires anamata, very high plastic deformation. Malleability is about making into sheets. Strength is basically a general term, okay na? Ability of a material to be flattened to sheets is not called as strength. Every material will have its strength. Strength is basically the stress at which the material fails. So it's corresponding to the stress. It's the stress value at which the material loses elastic deformation or elastic properties also in one way. Clear? So we can say this is not the answer. And rigidity. Rigidity is a virtual or very imaginary property. No material on earth is rigid actually. Clear? So rigid means it is not capable of changing its volume or shape. It is exactly at the same way it was actually produced, or whatever the way in which it is actually there in earth, it will be in the same shape and volume, which is not possible for any material. At some value of stress, the material will fail. So the correct answer is option number B, which is malleability. So question number 127 is done. Let's proceed to question number 128. So blast furnace is used to produce. We have already seen blast furnace is used, or basically the process which occurs in blast furnace is smelting process, where the iron ore is reduced to pig iron. So in blast furnace it is used to produce pig iron, it is not produced to wrought iron. Puddling is the process which uses pig iron and converts to wrought iron. Clear? And already cast iron is there, okay na? So pig iron is a general term and cast iron is an example of a pig iron. Pig iron can have few more impurities as well, but cast iron will not be having any impurities at all. And mild steel, it is a low carbon steel. Again, you need to create wrought iron and later you will be adding some carbon and producing low carbon steel up to 0.3% of carbon, which is mild steel. Clear? So this is the answer for this question, which is nothing but pig iron. Clear all? Let's proceed to next question. Question number 129. Question number 129 says, the resistance of a material to elastic deformation is called as. So basically stiffness is the word, because resilience means the energy the material can take up to elastic deformation or elastic limit. Energy. So resilience is regarding energy. Okay na? Resilience is regarding energy. Resistance regarding energy absorption basically. Clear? So this is the one here. Next, hardness. Hardness is how strong is the material on the surface. Next one, ductility. It is about the material to undergo some plastic deformation after elastic deformation. Every material will undergo some elastic deformation first. Even if you take concrete, that will have some elastic deformation. After elastic deformation, it will experience some plastic deformation. So that should be larger for a ductile material. Then only we can use it to make into different shapes. For example, if you take aluminium, aluminium is coming in types of big billets, big blocks and all, that is used, that is rolled and produced with small thin sheets of plates. Those are used for thin sheet, or even wrapping papers are made up of aluminium. Clear? So that needs to be ductile in nature. Clear? So ductility is that value, hardness, resilience we understood, stiffness is the thing. So stiffness decides how much elastic deformation it can experience. Let me give you the formula for stiffness as well. Question number 129. So we need to get stiffness. Clear? We need to get stiffness. So basically if you see, change in length is equal to PL by area into Young's modulus, where P is applied load. Okay, now this is elastic deformation. P is applied load. L is length of the element. And A is area of cross section, okay, and E is Young's modulus. And this stiffness is equal to given by, okay, stiffness is equal to given by force P by delta L. So this comes out to be force P by delta L, this comes out to be AE by L. So more is the stiffness means larger value of load is required to create some value of elastic deformation. Very large value is required to create some elastic deformation. Very large value is required to create some elastic deformation. Lesser is the stiffness, that means numerator is lower and denominator is higher. Understand? That means easily with a lesser value of force, it can experience good amount of elastic deformation. So the correct answer for this 129th question is nothing but stiffness, which is option number A itself. I believe it is completely clear to you all. Let's proceed to the next question. Next question is anyways theoretical one. It is given that gunmetal consists of option here 10% tin, 88% copper, 2% zinc. So option number A is right. So this is a theoretical one. There is no other way to, there is no other point in discussing regarding this. So the answer for this question number 130 is nothing but, it is nothing but option number A. Clear all? Okay. So let's proceed to the next question. Question number 129 is there, 130 here. 130 is done, this is 131. So in this 131 you see here input of additive manufacturing process. Okay, input of additive manufacturing process. See here CNC data, CNC machine basically used for cutting. It's basically an automatic machine or automatic lathe. So lathe means it will be removing the machine, so it is not an additive manufacturing process. So we can eliminate option number A, CNC machine. Clear? CNC is cutting here. DNC is also similarly something like that only. Okay, next one, production planning and control data. Production planning and control data is about management. Okay, now it is about managing, industrial management and all like that. Clear? The only correct answer is CAD, computer aided designing. So basically here using a computer you will be doing the designing. You will be using softwares like AutoCAD, CATIA, Hypermesh, etc. and you will be doing that particular thing. Understand? And then using the design you will actually produce this particular element. Clear? So CAD is the correct answer for input, as an input for additive manufacturing process. I believe it is completely clear to you all. I hope there is no confusion at all. And let's look into the next question. It is given that CAD CAM is a relationship between, very simple here, look, CAD computer aided designing, CAM computer aided manufacturing or machining. So simply design and manufacturing would be the appropriate answers here. Science and engineering, no, very vague statement. Okay, na? Very generic question, generic statement, which is wrong. Manufacturing and marketing, no, we never ever hear the word as marketing when you study about these CAD, CAM or any of the mechanical engineering. Design and marketing, again marketing term is there, so this option is wrong. So three options are wrong. The correct answer is only option number 1 here. I believe it is completely clear to you all. So for this question, CAD CAM is the relationship between design and manufacturing. Clear everybody? Clear? And next one, again simple one, CAM database system is extensively used in. CAM database system is extensively used in, first one, numerical control part programming. So basically CAM term you never ever hear in lathe, milling, jig boring. వీటన్నిటి గురించి నేర్చుకున్నప్పుడు ఎప్పుడు కూడా వినము. సో లైక్ దట్ యూ కెన్ ఎలిమినేట్ దీస్ 3 ఆప్షన్స్ అండ్ యూ కెన్ గివ్ ది ఆన్సర్ as option number 1, numerically controlled part programming. So you are actually numerically controlling part programming. So basically computer aided manufacturing is database is extensively used for numerically controlled part programming. Clear? Understood? So this is the one. We are done with question number 133. Clear? We are done with question number 133. Fine all. So we'll stop here. In the next video we will continue from question number 134. Thank you so much everybody. All the best. Let's meet in the next video. Bye.